Second attempt, maybe with the top of my head this time. I noticed it was missing yesterday. Now, today, rate graphs. But before we do that, there's a little thing we kind of need to be aware of, which is what can we measure? Now we are talking in the context of rate of reaction, we're not talking the length of a Formula 1 race or anything. What can we measure in terms of rate of reaction? Now if you think back to the very last lesson that we had before all this unpleasantness kicked off, we were measuring the mass loss of calcium carbonate in hydrochloric acid in a conical flask. So mass loss, something you can measure. And these are all against time. So mass loss, yeah. It was carbon dioxide. So you can do that. You can catch the carbon dioxide. It's a little more fiddly than that. So I prefer that one personally to that one. People always get in a mess doing that one with upturned measuring cylinders and stuff. I don't know whether you did that before. I've seen lots of people fiddle about with that. Now, there are other things you can measure that will change as a reaction takes place. If you're doing something with an acid and the acid reacts away, the pH will change, so you can monitor the pH. It really is, of course, related directly to the concentration of hydrogen. So, there we go, like that. Now, other things you can measure, well, you could just literally titrate, take out bits of the reaction mixture and titrate it. You have to have a big reaction mixture, big bottle of reaction mixture, take out bits, titrate it. It's possible. You could watch the colour change. We had iodine a few weeks ago. Iodine in aqueous solution is brown. As it reacts away, you saw it in a titration fade and fade, it became yellow. So you could monitor that. There's a piece of more biological equipment in terms of how many times you use it, called a colorimeter. Ah, no, you hate that, American. So we can monitor the colour. And there are lots of other things, but that's just an example of 5 things that you can measure. Remember, these are at time interval. They don't have to be the same distance apart, providing you know which time, and then you can plot a graph, which is why the title is there. So, at this point, we're going to stop. See, little pause, wipe the board. Now technically those things should be so you find the value it got to at the end eventually, and then you've got your current value, and it's taken away from that. This is obviously after the experiment because you can't get that till the end. But I find that for what we're doing, just going with the value that we've got is good enough. Now, when we talk about rate graphs, we are looking for, hide the yellow cloth, we are looking for time as the independent variable, and then whatever thing we have been measuring against time. Now if we link back to us sitting around recording the time, recording the mass of the conical flask and the cotton wool and all that business, so we can think about that. Now I did ask you to plot this graph, if you recall, but unfortunately we didn't get to do the second part, because the second part will be where you have, well, we put an equal amount of water in as there is acid, which dilutes the acid by half, and then we do the plot again. So the plot that you could have done, and I'm hoping you have done, goes like that, let's say. Now, it always flattens off. Why does it flatten off? Well, the acid's running. So the concentration of the acid goes down and down and down and down. Eventually, the reaction grinds to a halt. There's always more when you do these things with marble chips, always more marble chips than acid in terms of moles. Acid runs out. Now, the mass loss, cumulative mass loss, climbs up, eventually flattens out. If we do that with more dilute acid, now if we did it in the way that we did, which is, I put 25 of acid in that day. If we put 25 of acid and 25 of water, the concentration of the acid is halved because of all the water, but there's still the same number of moles of acid. So what will happen at half the concentration is the reaction won't go as quickly. I hope you realise that it was not going to go as quickly, and it would go up, and it would eventually end up at the same place. There, they would end up at whatever the total mass loss was each time, but it would be the same mass loss, give or take a little tiny bit. It's a real experiment when you do it. So how do you know which one was the dilute one? That's the dilute, or diluted, because the other one was dilute as well, and that's the original one. And the reason? The gradient on the diluted one is not as steep, so the gradient there is not as high as the gradient there. I'm hoping you remember how to do gradients. What do you think? Do you remember? Now, the good thing about, well, these ones with calcium carbonate and acid is that it tends to be quite close to a straight line. So the straight line at the beginning makes it quite easy to measure the gradient straight, is pretty much a straight line, so therefore you just literally go, oh, there's a straight line, and you do that. Y divided by x. But of course, really, it's the change of each. Now for those mathematicians, I'll try that again. Mathematicians, it's dy divided by dx, but that just means change. To a mathematician, to a chemist, it means dipole, but splitting hairs. So, but what we must remember is that we must do the y over the x, not the other way around, and therefore we get a measure of how steep it is. Now, if I diluted the acid with equal amounts of water, the volume of water will be the same as the acid, and therefore the concentration will have halved. The gradient of the diluted one should be half the size of the first one. It rarely is in the real experimental world, but it kind of does a reasonable job of that. Now, so we've covered y ends up at the same point. You sometimes get asked that kind of thing. Second thing is we've covered, oh, it's a gradient. So you literally you don't measure it in centimetres or millimetres or whatever. You look at how many minutes it equates to, and you look at how many grams it equates to. So it's y in grams over x in minutes, and that'll give you a gradient, and the gradient is the gradient rate in grams per minute. Well, we don't like that, do we? That's GCSE, we know that. You know we do that kind of thing. Min to the minus 1. Really, it's supposed to be per second, but it's whatever it is, whatever you choose to do. Dot the R. So, that's fine. But what happens if you have to do, how fast is it going at that point where I put a dot? So what happens when you've got to do that? Disaster. It's not a straight line, it's a curve. We need to pause. And unpause when we've picked up our ruler. There it is, I've got it. ruler. I don't know if you can see that, it's obviously a clear ruler, but you should better see it against there. What do you do when it's on a curved part is you do what is termed, and you may well have done this before, yeah, got to put an N in, tangent. So you do a tangent. Tangent is the correct thing, is that's the tangent. Try not to rub out the writing on the board. That's the tangent. What it's not is that, where it covers up part of the line. I dropped the ruler! So, anyway, there we go. It's a line that never crosses the actual line. And then, that then gets its own gradient. One of the things about doing gradients is don't do them little diddy tiny ones. You need to do them reasonable sized, because that way you get less error, and you are marked on the exam questions whether you're within their selected range of what the gradient should be. So if you do it little tiny and you drift outside the range, lost marks. And we're not here to lose marks. I said that yesterday. So you do a tangent line and then you do the gradient again. So if you're asked to do it as a how fast is it going in terms of the rate on a curved part, you do a tangent line. If it's on the early part, it's just a straight line. You can come back with a ruler. You can just go, oh look, it's a straight line, extend the straight line and do the gradient of that. Those are possibles. I don't know what to do with the ruler now. Put it in my pocket. Right, so yeah, there we go. Now at this point we have reached the point where you need to do something, so we are reaching one of those things where we're going to pause and you're going to go away and answer an attached sheet in the Show My Homework, which has got some data sets in it. You're going to plot the data sets, and the ultimate thing of that is how much was the acid diluted by to get the second set of data. So now is the time to pause and do some work. Well, if you've plotted the data and got two graphs, you do need, I didn't say, but it says it on the sheet, that you should plot them on the same axis so you can make the comparison straightforward. So the graph would look like that, time there. You're going to have two graphs that go up to the same point, and the dilution three. Now, like all real sets of data, there's a little bit of wibbly wobbly on the line where points are not perfect, because that's what the real world is. So it would have been that to dilute it by 3, the example would be 25 centimetre of acid, 50 centimetres of water. That makes it 3 times weaker, so that's a 3 times dilution. And then there were the other answers. Well, those will be mark them yourself questions, which means there's only one thing left to do. And thank you for your kind comments on the my initial attempt. I've never done anything like this before. I even got a comment from Canada, weirdly. The final thing is that there are a number of examination style questions in another attached document for you. Now, some debate about whether I want you to submit them or whether I want you to send me the answers. It is proving a little tricky to send me the answers, so I do realise that maybe I should just put the answers with the set piece of work, except that I often don't have them when I put it up there, so you have to keep coming back to the Show My Homework, and it will be updated with additional documents as I finish the things off, because it is kind of important that I get these things up. This is obviously got to go up for the next time we have a lesson timetabled. Or if you're not one of my class, thank you for watching. Time wise it makes no difference at all. Please let me know how it goes, and again, like before, email me teverett at the usual domain of the school, and if there's anything you get horrendously stuck on. I was thinking you should all be subscribed, which means there should be 7 people subscribed. Only 4 at the moment. Hopefully that will rectify very soon. So thank you, and I look forward to seeing you again in a couple of days' time for the next instalment of Adventures in Chemistry, quite frankly. Thank you very much. Goodbye.